Les presento brevemente a Carolina. Carolina es de Brasil, lleva bastante tiempo trabajando ya en todo este tema de Elixir. Trabaja para una empresa que yo creo que es un modelo a seguir dentro de una fintech, que es el Nubank en Brasil, el banco virtual más grande en Brasil, que hasta la fecha está cotizado en 10.000 millones de dólares en Estados Unidos. Entonces es una bonita experiencia tenerla aquí. Y para los que no sabían, también el Nubank hace parte, uno de los dueños es un colombiano. Entonces es un placer tenerla acá, Carolina, experta en café, también le encanta el café, estuvo por ahí en Twitter en algunas partes de café. Así que, Carolina, bienvenida, muchas gracias.
Hi everyone, so today I'm going to talk a little about how you can build a sustainable architecture. So as I was introduced, my name is Carolina Pascale Campos. I work as a software engineer at Nubank. I love books, coffee and running, and I just had some really nice coffees here in Colombia, so I'm like really happy. I went to Rituales yesterday and it's like, wow, this is like real coffee, right? So it's been a really nice experience here in Colombia, so thanks everyone for having me here today. So what's the motivation for the talk? The motivation is that I just started at Nubank in January, and I entered in a new squad. We had a tech manager, me and Marcelo, another engineer, and he entered the same day as I did. And we needed to start a new service because our squad was new. We didn't have implemented services, so we needed to start a new one from scratch. And our tech manager just went on vacations and was like, wow, how I'm going to deal with that, because we are new at Nubank, we don't know anyone here. Our tech manager had already 2 years experience there, so should be the one that could help us in that way, but she went on vacation, so we said, okay, we need to deal with that. It was really crazy for us because we just opened GitHub, opened a lot of repos, and okay, this one looks nice, so let's use them as a source of truth because it seems okay, and we started developing. And what shined for us, it was like a really smooth learning curve. We didn't have much guidance, but we are already delivering tasks, only the two of us in a new company, only looking to the repos, and that was really, really nice. So we could ship code to production in less than 1 week in a new company. So almost no guidance, our tech manager was not there, we didn't know anyone in the company yet, and then we started to talk to each other to understand what was happening. And the question that came was why? Why we could deliver so much code with almost no guidance, so fast, ship code to production, be confident with that. What are the reasons for it? And that was the motivation for the talk. I just stopped and trying to understand what were the patterns that led us to that. So talking a little about Nubank, I don't know if anyone here has already heard about the company. It's growing like really fast. We started with a credit card product, and the idea is that everything is digital. We don't have any physical place, only for the engineers. And we want to offer something that's completely free. We don't have any fees. People can just use. It needs to be easy for everyone. We want to give you control of your money. And so that was the first product that we released, like I think almost 6 years ago. After that, we created another product that was the reward. So when you buy things, you get points that you can trade. You can like erase things from your bill. And the one that it was one of the last is like the Nu Conta, and the idea is that you have a digital bank account where you can pay your bills and you don't have any fees. That's like the special thing. Like you're going to transfer to another bank, so you don't need to pay anything for that. And when your money is in your account, it's every day you have interest for that. So it's really nice, and it enables us to grow much faster, because when you have only credit products, you can release that for everyone, because some people have some problems with credit. But when we started like with no conta and debit, we could just grow our base much faster, because now we can give those products to everyone. And talking about the size of the company, now we are more than 300 engineers. We have more than 300 services, so almost one service per engineer. We have more than 40 squads. Now we are in 3 countries. We started in Brazil. Now this month, we started releasing our credit card in Mexico, and we started our office in Argentina. We still didn't release the product there, but we already have some engineers, and we have more than 15 million customers. Last year, Forbes said that we are the best bank in Brazil, and we are the biggest digital bank in the world, except from China, because it's really hard to compete with China. But we are growing really fast in the last 6 years, and we also have our customers. They said that like Nubank is the best bank in Brazil because we have a really good customer service. We really care about our customers. That's another thing that differentiates from the big banks, that you have a lot of bureaucracy. We just want to be transparent with our customers. So that's just to give a little bit, to give an idea about Nubank. Okay, so when we are talking about that much services, imagine how hard it is to understand what's happening in our code base. I watched the other talks, and they are saying about all the distributed system problems. I'm going to focus more on the code base part. I'm not going to talk much about the communication between services. So. The thing was, when I asked the why, I started to try to find the patterns among those services, like why all of them are working, what do they have in common, why it was so easy to develop a new service, even being a newcomer in the company. So what are the things that they have in common? And what I found out was all those services are using functional programming, all those services rely a lot on tests, and all of them are using hexagonal architecture. So those are the things that I said, okay, when I look to all of them, those are the things that are the same. And I remember when picking the first tasks that those things were really important. So I'm going to talk a little bit about all of them, and after how they compose together. So talking a little bit about functional programming, when we talk about functional programming, we want to talk about per functions. So given its outputs, I can always return the same output. Given its input, sorry, I can always return the same output, and I'm not doing any side effects. So I'm not writing something to the database, I'm not sending an email, anything like that. So I have the inputs, same outputs, I'm not doing anything with any side effects. It's also about referential transparency, because the idea about referential transparency is that you can remove the function and use the result of that. So if you have per functions that are not doing those things, you have referential transparency. So those concepts, we can say that they are interchangeable. And the idea is that we as functional programmers borrow this concept from math. So when we talk about per functions, we are referencing mathematical functions, right? So they are different from methods, they are different from procedures, where when we talk about methods or procedures from other languages, we know that we can write things to a file, we can don't return anything. So we can do a lot of things when we're talking about methods and procedures, but we don't want to do a lot of things, so we want to narrow our view. So we want per functions because they don't have all that power. So it's a similar, the idea is really similar to math. When in math, we usually talk about domain and range, and when we are talking about programming, we are talking about arguments and return values. So it's the same idea. Those mathematical functions, they are pure, they're referentially transparent, and they are timeless. It doesn't matter when you're going to solve that function, it's always going to give us the same output. So what about the impure functions? Because we know we want a useful code, right? We need a way to get in our program. We need a way to give a result. So as much as we love to talk about impure functions, we need to think how we are going to deal with the impure ones, because we are going to have them. So we need to think how the pure functions are going to interact with the impure functions. I don't want to mess with my code, so we need to be really careful about these impure ones, because they change state, they change if I run that today or if I run that tomorrow, things are going to be different. So they are harder to deal, but I need to deal with them. And I need to think well when dealing, because otherwise they're going to mess with everything. So we need to talk about side effects. How are we going to deal with them? Because we have, when we are entering, when we're leaving the program, when we're sending emails to our customers and all those things. So one thing that's really important to have in mind is that if you're writing a pure function and you call an impure function inside of it, you just make your pure function impure. So imagine that you're creating your functions. You always need to think about that. Like, okay, now I'm writing a pure function, so I can't call anything pure. So how I'm going to architecture this flow so only the impure functions are going to call the pure, but the pure are never going to call the impure. So I need to think how you're going to structure your functions so you have the right flow and you're not infecting things. So it's a thing that you need to think when writing your functions. You want to structure your code in a way that can maximize the pure functions that you have. If you don't think about that, you're not going to do it. So that's the point. We don't want to infect our function code with imperative code. So the idea is that when you have pure functions, you have functional programming. When you have imperative code, when you have impure functions, you have imperative code. And when we are programming in a functional language, we want to have as much functional code as we can. So how can we structure things to isolate our impure functions, to put them in a shell so we know they are safe. Our pure functions are going to be safe from them. So that's the idea. When coding, you need to think, I'm going to limit the amount of imperative code so I can leverage things. And the thing that I like to say is that if your function could be pure and it's not, maybe I do it wrong. Like, look to that and try to change. If it could be pure, it should be pure. So be really mindful about that when developing. So talking about a little bit about immutability and mutability. I really like these drawings. It's from Joy of Closure, a really nice book. And it gives a really nice base about functional programming. And the idea here is like your book is your identity. So when you want to change something in the draw, what you're going to do is like you turn the page and you're going to make a new draw. So the act of turning those pages means that it means the state during that time. So if I stop on a page and observe it, that means that was the state in a certain point of time. So when I'm like flipping those pages, I'm seeing the state in certain points of time. And if you have mutability, you just lose all of it, because now you have identity and state as the same thing. You lost the notion of time, because if you're going to draw something now, we're going to erase and we're going to push something here. So when you look to the draw in the end, how can you know what was like before that? How was the beginning of that draw? You don't have that anymore, because you just mixed these two concepts. Your identity and your state are the same, and you don't have the time power that gives a lot of power when you're trying to debug things. So functional programming gives you a lot of power when you have pure functions and immutability. So it's really easier to reason about your code. As I talk about refresh and transparency, imagine that you're seeing a call of a function and you can just replace that call with the result. So it's way easier to reason about that code. When you're going to debug things, you know that given that input, the output is always the same. I don't need to create a lot of state to get to that point point to understand what went wrong. So this combo is really powerful, and that's the reason I was talking to you, that we need to have as much as we can of it. We need to have as much per functions, at as much immutability as we can, because we're going to move way faster if we have it. So that's the reason we want to be mindful when developing about those things. And it's really nice because when we are using functional language, you have persistent data structures, and so you don't need to worry about performance. Because the idea is that when you are, we call that copy and write, so imagine that we're adding a new hash map you're adding a hash map, and then you can use the existing values from the old one. You're going to make a copy, but you can reference everything that was from the old, because the immutability idea. I can use the things from the old one because they're never going to change. So given they are never going to change, imagine like a graph, I add something new, and I have the safety to say, since those things are not going to change, I can just copy and add new things. So we don't have any performance problems. Usually that's a thing that you worry when you're like developing with JavaScript. Once you have a function of JavaScript, you can, but you don't have those kind of things. So you need to use some libs, for example, some libs that give you immutability, but it's really nice when this is already in the language. So you have that with Elixir, you have that with Clojure, so we don't need to worry about this performance thing that we're just creating a lot of new maps, for example. And you can focus on what matters. So that was what I was trying to say when we developed a lot of code in 2 weeks, we shipped things to production. We are not like having to do a lot of things, having to create a lot of like object-oriented things, like you just write a lot of codes, a lot of boilerplate, and you don't get to anywhere. No, in those 2 weeks that we were alone, we were shipping business code, we were shipping things that matter. So functional programming gives you those powers. You can move faster because it's easier to test, everything is way easier, so you can focus on what's really, what really matters for your business. And another thing that's really powerful for debugging is that when we eliminate shared states, so the order doesn't matter. Because when order matters, it's much harder to understand how things are happening. You have to create those states, because in that, things happen that order, and when you need to debug a function, but you need to call order 10 to understand what was happening. And when you eliminate shared state, you give a lot of power, because those functions are going to be independent, they're not going to share anything with other functions. They can run in their own pace. They are not going to mix your word. It's like Eric Normand has a really nice analogy to it. It's like when you have to dig a hole. Imagine that as many people as you have are just going to give shovels to them, and they're going to dig. So as many people as have is great, because they're not sharing their tools. Like, okay, I'm going to get out some sand, and now I'm going to pass to the other, so the other can. It's really hard. You just lose a lot of power. You could paralyze things, but you can't. So these are the power that you have when focused on doing a lot of pure functions and a lot of immutability. You can eliminate this shared state. And as I was saying, you don't have to set a lot of things before starting. So the idea is that I want to be as functional as I can. I want to write as many pure functions as I can. I want to have as much immutability as I can. I need to think about those things. I'm going to talk a little about the architecture after, on how to structure it. Before, I'm going to talk a little about tests. So when I have per functions, it's great for that. It's really easy to test, and what we want here is to have a sustainable code base. So tests are really important for that. They're important because they give you confidence, they give you safeness. If someone new is entering the team, when it's changing some code, it's going to break things, it's wrong. So you can move better by yourself, because you don't need a lot of guidance. Things are going to break. Okay, it broke, I can change here. So it gives you confidence to change things that code base. So it's really, really important to have tests. And it's a live documentation, so documentation is a really big thing to talk about. Some people like, some people don't, but tests are great for that. So when you have a function that you have never saw, some other people developed it, you just go to the test and say, okay, when the people developed this function, it was expecting this, this, and this. It's written in the test. So it's really powerful, and they don't get stale, because if you change that function, you're going to need to change the test. And when we are developing, we need to know if our program is doing what we expect that's doing. So we need to have the feedback, and we get that feedback from the tests. But how good is the quality of this feedback? And a good spoiler here is that's not about 100% of test coverage, because that doesn't mean almost anything. We want to have a solid feedback. So the first point here is accuracy. So if a test that you wrote fails, do you know exactly what portion of that code has failed? How long it takes for you to understand where that failed. So as granular as it is, it's going to be easier for you to find where the problem is. So again, pure functions, they're independent. They receive the inputs, the outputs. So if something fails, it was that pure function that failed, because it's not interacting with others. So we have a lot of accuracy when doing that. So we have small functions, pure functions. They don't depend with the outside world, and you get accuracy with functional programming. Also about the speed. If your test fails, the sooner you identify that problem, the smaller it will be the impact. Imagine that it takes a lot for you to write a test, there's a lot for you to run those tests, so you just lose a lot of time to get that feedback. So what's really the point? You need to move fast, you need to have a fast feedback. And sometimes when you have to mock a lot of things, you can't forget about mocking things, and those tests are going to take long to run. You need to create all that state. It takes a lot to write integration tests, not as fast as unit tests. So the speed here is not only about how long it takes for you to run the CI, but also how long it takes for you to develop those tests. And it's really important here that we need to have a reliable feedback. If we have tests that sometimes pass and sometimes fail, and you didn't change anything in the code or in the dependencies, what's the point of having these tests? You can't rely on them, so just erase it. You know, there's no point. You say I have tests, but sometimes they fail and sometimes not. And it was happening with us, because usually when I talk about this, we're talking about E2E. And E2E is a really big problem when your services are growing. So imagine at Nubank we have more than 300 services, and in the beginning we had E2E, and we need to, like, those services need to go up, we need to say things we really say things in the database, we expect those messages to pass, and we know that those kind of tests, they really fail for obscure reasons. So they fail because of garbage collection, they fail because asynchronous is hard, and they take really long to run. So imagine waiting 5 hours for your end-to-end test run, and they fail, and the reason was that you have no idea, because they are interacting with so many services that how are you going to find, like, the accuracy thing? How am I going to find where this failed, you know? And if you find, you're going to wait for another 5 hours. It was really unsustainable at Nubank. And there's another problem. We organize as squads. So when you create a new feature and you're talking with the other 10 services that are not yours, who should write that end-to-end test? So that's another problem. So, oh no, it just takes one line of my code. So I don't need to write. Another squad is going to see this flow and write for me. So that's another problem. And we decided that we're not going to have end-to-end tests anymore. They are not scalable. We're taking a lot of hours to run. We could ship things faster to production and get a feedback faster. So for example, canary deployment, it's way faster. I can just ship that for 1% of my customers. If something fails, it's going to fail in production. I can deal with that, and I'm going to fix, and it's way faster than waiting for 10 hours. So how much money am I losing waiting for those tests? This feature could be released this week, but it can't, because I'm waiting for my tests to run. And another thing that we realized after using like 4 years of end-to-end tests, as they were not almost caughting any errors that we didn't expect. So they were taking a lot to run. They are not giving us valuable feedback, and we decided that we should use another option. So canary was a thing, and the other is like, when you have your unit tests that guarantee the functions are working, then you have your integration tests that guarantee that the flows from that service are working. So, oh, I have all those flows, I'm testing with the integration tests. But the problem comes when you need to know if the services are communicating with each other. That was what E2E was giving to us. But when we need to test things, we can think only a little bit larger. So I have my service, and it's going to talk first with another one. So what I need to comply is with this contract, with these two services. Okay, but after this one's going to talk with another one. Okay, so now I test these two. So you're thinking only a little bit larger, not like 10 services at the same time. You don't need to test everything at the same time. So I decided to have contract tests. And the idea here is that you're going to have a provider service and a consumer one, and you need to verify that the communication between them is working. So they need to have a clear interface to communicate. That's what we call a contract. And we need to have automated tests that guarantees that if you change something in the contract, can the consumer still read what the producer is doing? So now I can guarantee that things are working, and is not an one-to-one replacement with end-to-end tests. It's really important to make that clear, but it runs really fast, and now I added another layer of confidence because I'm guaranteeing the contracts. We can have errors, so let's use canary deployment and things like that. But this year we ended with all our flows using end-to-end tests, and it was great. Like, since this year, things are faster to go to production. We are really happy that we killed end-to-end tests. So nice. Using those ideas from functional programming, we have the accuracy, we have the speed, because it's really fast. You're like developing your function, and you can, if you have, your language has a REPL, like Clojure, you can just go to the REPL and test things really fast, even before writing tests. And you have reliability, because per functions, as I said, same input, same output, almost no shared state. So you just get everything that matters for your tests. And why do we want to have highly testable code? Because we want to have safety when developing. We are onboarding like a lot of engineers and no bank, and we want them to feel comfortable to start working by themselves. And if we have tests, they get confidence, because they don't need to ask things all the time. They can see the test passing or failing. They can write no tests for their features, so when they open a PR, they say, oh, at least my tests are passing, you know. It gives you confidence, and it's really good for moving faster. And now, how should we design that code, you know, to get advantage of all those things that I told you? What we want to do is high maintainability and low tech debt, because we want to have applications that are simple to give maintenance and are easy to work on. So we need to have always that in mind when developing. And sometimes it's a hard thing, because when you think about giving maintenance, you think that's a long-term concept. So when you start your new product, what you think is like you have two developers, so it's really easy to just add new things. This is like, we have like 5 files, so everything seems really easy to develop. You can see how important is maintainability. But if you don't think that since the beginning, when your programs grow, you just grow a monster, because you didn't think that in the beginning. So it's really important to really think that things are going to grow, and you need to take care of it. So think about that since the beginning. You're not going to see all the advantages in the first month when you have 5 developers, but when you get to 100 developers, you're going to say, okay, those decisions were really important. And you don't want you write your program all over again because you didn't make some time to think about how to architecture it. So our first attempt at Nubank was to use hexagonal architecture. So the idea here is that you have a domain model where you have all the functional implementation. So we are going to translate your domain to the code, and you only have to have pure functions and immutable data, because imagine that you have like an accountability system, and these things are true for many years. Like those functions, they don't change the result. And you're also going to have some things that change a little bit more. For example, your business rules. So do you charge things, or do you don't charge things? But all those functions are going to be pure and immutable. So this is why it's green. It's safe. And in the second layer, you have your application. So we can think here about the controller. You're going to receive some HTTP call, and you're going to pass that to an adapter to make the data as your service is waiting. And the controller gets is to say, okay, I need to call this domain function, this other domain function. I need to save this to the, I'm going to call the function that saves it to the database. I'm going to call the function that produces a message. So the controller is responsible for orchestrating that flow. And unfortunately, here we have impure functions and we have mutable data, because in that functions we are really calling like save to the database. We're going to like produce that message. So our second layer is like a little bit infected. And the third layer is where it's really like the I/O happens. So here our request is going to arrive. We are going to produce the message. We're going to save to the database. We're going to retrieve a file. So that third layer is responsible for receiving all the inputs and outputs. That's the I/O. So here it's okay that we have the impure functions. They should be isolated here and controlled. We need to have them somewhere, and this is where they should be, only in the I/O. It was our wish. So hexagonal architecture, the idea is that you can separate your business logic from the I/O. So as I showed you, you have that shell for your domain. You are protecting things. So you can separate like the business rule, the infra code, the application code. So it's easier to give maintenance to that. When you have a task, you know the layers that you need to change. Or for example, I'm not going to do HTTP call here anymore. I'm going to use a Kafka message. So you're just going to change the infra layer. Your domain is really safe because you didn't mix the concerns. So that's the idea from the hexagonal architecture. And you can have tests in isolation with mock and stubs. And why? We don't want to rely on external APIs or real database to test things, because it takes a lot. And we want something that's really easy to mock. And the idea with hexagonal architecture, they say, oh, use dependency injection. So your controllers are going to receive the dependencies. You're going to receive your database. You're going to receive your producer and things like that. So it's easier to, when you're doing your integration tests, you're going to mock things so you can test them. So that's the idea from hexagonal architecture. And okay, given off that, I found that point, and okay, I said, okay, maybe I found something, a reason for being so fast to develop when you have all of that. And the idea here is that hard things with oriented objective programming can be easily done in functional programming. And one of them is tests. And why? You have the boundaries. So I show you the hexagonal architecture here. You have your impure code protected. It's in the boundaries. And this is where we generate side effects. And it's really nice when I look to my code base and say, I know where my impure functions are. And they are not all over my code. They're just there. So that's powerful. And what's the concept of isolation? This concept is that a function has all the info that's needed from the outside passed through arguments. So all the things that my function needs are going to be passed to it with arguments. And I'm not using some global state. I'm not going to use global variables, things like that. So let's see here. When I see that, I think you remember about per functions, because if given an input, they always return the same output. That's true. And it's not only per functions that are isolated, because imagine you can receive all the things in your arguments, but you can't call like save to the database. It's still isolated. You're not using a database that's global. You're receiving that via arguments. So it's still isolated, but not pure. But the power here is that when I say pure functions, they are a subset of the isolated ones. So all the pure functions are isolated. So that's the power, the subset. Encapsulation, it's a problem, because it's almost the dual of isolation. The idea about encapsulated code is that an object has a state, and the world knows nothing about me. If you want to know something about me, ask me. So I can give you, and if you want to change something inside me, you need to ask me. So you don't know nothing about me, and I know everything. Isolation is the opposite. I know nothing about the external world, and I ask you, please give me things so I can work. So it's like the dual. But when you have isolated functions, it's really easy to test. You can test things really fast, like pure functions, functional programming. Unit tests, they are just for free. But imagine that in object-oriented program, that's a problem, because encapsulation is a thing there. And you don't want to don't do encapsulation when you're doing object-oriented programming. But it's way harder to test. So when you're going to have this setup, it's going to cost you a lot of time, it's going to cost you a lot of effort, because you need to have an intersection here. So pure functions are a subset of isolated ones. You don't think about isolated functions when developing, since they are subset. But isolation and encapsulation is an intersection. So it's way harder to live in an intersection than a subset. So that's the problem. It's really hard to find that balance, because I want to have encapsulation and I want to have isolation so I can test things. And we know things in object-oriented programming are hard. You have like these 700-page books with a lot of design principles, and someone new come to that code, and they have no idea about all those things that are happening. So they can do wrong things that are not going to fail in the tests, and no one's going to tell them, oh, okay, someone can tell them that's wrong, but you could like do 2 weeks that are going to the trash because you didn't know about those concepts, and that's okay, you're just starting, that's not a problem. But OP is giving you a hard time. That's the thing. You want to move fast, for that you need tests, because you want confidence, and if that's not easy in object-oriented programming, it will be a problem for you, and not a problem in FP. So that's the thing I realized. That was the reason things were moving so fast. I had the test, I had that feedback, I didn't need to write a lot of boilerplate. And the nice thing is that hexagonal architecture in FP is natural. And a nice programming language for you to realize that's Haskell. Because in Haskell, when you are writing a function, it expects it to be pure. So if you're doing pure code there and you don't say anything in the type that's an IO, it's going to fail in compiling time. So you have this feedback to say, okay, I thought I was writing a pure function, but I'm not. The compiler just said that I'm not. And I wish it is. So I'm going to change those things here. I'm going to move the side effects to there. Okay, here I have side effects, IO, that's okay. And so you're developing, and the compiler is there right by your side as telling you those things. Like with closure, for example, you don't have that. The compiler is not going to fail if you write an impure function. But with Haskell, it's really easy to find that you are going to push impure code to the boundaries. Your compiler is telling you to do that if you want to have pure functions. So you're going to, okay, I have this pure function. The impure can't call the pure runs, so I'm just like moving them really to the boundaries and making my domain as functional as I can. So that's really nice, because Haskell helps you to get to that reason, you can understand when you do Haskell. So when you're doing functional programming, a good functional programming design is port and adapters, because the idea of hexagonal architecture or port and adapters is to have your ports. There is where you should have the impure code, and that's just what you get when you are doing functional programming and thinking about, okay, I want to have as many pure functions as I can. So that's natural. That's why those things fitted really well. We chose hexagonal architecture not thinking about all those things, but in the end realized that it's natural. It's how you do things. You push impure code to the boundaries. So that's another reason that was so easy to develop in that code base. We are doing something that we're not fighting against the language. That's a really big problem. Like, with object-oriented programming, when once you have isolation, you're fight against the language. And those things make it harder for you to develop and to be fast. So that was a great discovery, but we were not satisfied, because we thought, are we really leveraging functional programming to its max using hexagonal architecture? And why we were asking that to ourselves? Because our second layer had a lot of imperative code and side effects, that second controller layer. And I just told you that if we could have pure functions and we don't, we're doing something wrong. So we started to question ourselves after like 6 months. We were happy, but then we're not, maybe that's not the best approach. So why didn't we want that imperative code in the second layer? Because it's really harder to reason about, it's harder to compose, to test, you have a slower feedback. So like talking a little about that, imagine that you're calling a function, block, and you're passing to that function a card, a database and a producer. What this function does before entering that function. You don't know if that function is calling the database, if that function is producing messages, because this function can like return a boolean, like true, I blocked that card. But you don't know, like the return of that function says nothing about it. So I need to enter that function. Okay, now I can look at the code. I'm seeing that's calling like an atomic update, and it's calling a producer. So this block function, when I look to it, I understand that it's calling a database and it's calling a producer. And the idea here is that I have indirect output because I'm doing things as inside the function. And I don't have, when you have direct output, everything that function does is in the return. But when I do indirect things, I don't know what's happening in that function before entering it and looking at the code. That's the problem of doing indirect output. When you call that function, it says nothing about it. It's harder to compose. And why it's harder to compose? So imagine that you have a map and you are calling for each card a block. Then you get an error in the middle of it. So you blocked some cards. You still don't have the notify effect because you are blocking each of them as you go. So you're calling like the datomics, you save that, but you had a problem in the middle. So it's harder now for you to solve that problem because you blocked some, others you didn't block, and you also didn't produce the notify for any of them because as you go, you had an error in the effect, things were not produced for the others. So harder to compose. Here is as I was saying, and you're passing your infrastructure inside your controller. So you're passing your DB, you're passing your producer. It's already harder to compose because you have infrastructure inside your code. So how you're going to do all those effects. Also harder to test because you have to test that layer, you have the mocks and integration tests. Harder to write, takes longer to run. You can like, oh, I have that function, but it receives a DB. How can I going to test that in the repo? I just can't. It takes longer. It's not a unit function that I can test in seconds. You can't. It takes a lot. So it's not good. We need and when integration tests fail, that's another problem. Because where did it fail? It's a flow, right? It has like 15 functions in that flow. Which was the function that failed? So it takes longer for you to find the problem. Another thing with integration tests. So that second layer is full of that. How I'm going to deal with it. And there is lower feedback, just what I said. Takes longer to run and things like that. And then you look to your pyramid of tests, and you have more integration tests than unit ones. And that's not the point of the pyramid, right? Why is that? Because your second layer is full of effects. So for you to really guarantee the flows, you have a lot of integration tests, and you have the unit ones also, but you're just changing the order of that pyramid. So that's the reason it's not good. So I'm losing some pure functions that could be there. I'm losing the speed of the test because it's not unit ones, and I'm losing maintainability. So, okay, we said, let's try another approach. We have our service here, we can try new things, and if they don't work, they're just going to impact us. What about hexagonal architecture with dependency rejection? So now my controller will not receive those dependencies anymore. It's going to reject them. And what's the power of that? I just decouple the decisions from the facts. Remember that function, the block one. What's the decision of that function? That function is telling me I need to save a new state to my database, and I need to produce a message. I just decided that, right? But I don't need to execute that. I decided, but I don't need to execute. I just can return the thing that I want to do. I want to decouple that intent of the function from the execution of it. So what's the idea now? Now when I call block card, it's going to return me data. It's going to return me, okay, I have some datums that I want you to save. They have this structure, like they have the ID, they have the status. It's the same thing that you're going to call the .save in the database, but you're not going to call it to that function. You just return that structure. And I have some messages also that I want to pass. So now when I call block card, I know everything that should happen that function because it had no side effects. But I call, I see the output, that's what I want to do. And when I look at it, this is the difference. I have the blocked card, and now I am returning what I want them to do. So that's the effect of update. It's just, I didn't do anything here. I just created a structure that my database expects, and that's the effect from the messages. What do I get from it? Oh, it's easier to compose. Now, how can I test? I just check if the structure was produced. It's a unit test. I just check if, okay, my database expects an ID, a status, and things like that. Is that what I'm returning from that function? It's a unit test. So I just got a lot of contests. It's easier to test. It's like new documentation, because now those controller functions that were only being tested integration things, I didn't know about each of them. I knew about the flow. Now I can know about each of them, because they have unit tests, and I know what they're doing. Way easier to compose now, because when I call the block thing, I'm not blocking anything. I'm just saying those 10 cards, these are the structure to block them. I did no nothing. And now I already compose with the notify. So I pass these effects to the notify function. I'll say, okay, you need to block, and add those other effects to notify. And when I try to do those things, they're atomic. Because they are not done like, okay, I'm blocking some, they fail, after this effect would be this one. No, I know all the effects that should happen. I try to do them. If they fail, okay, that's a problem. I need to act on it, but they are atomic. I didn't have that middle state that I was getting from the other thing. And I have a really nice thing that is data as first-class citizens. So, a secret, we use Clojure at Nubank, not Elixir. But we are talking about functional programming here, right? But in Clojure, I think that we love much is data. Like everything, Lisp, everything is data. And when you have those things, now your data is just flowing through your app, because I'm not calling the save. I'm telling you what's the object that would be being saved inside the database. I just got those data as first-class citizens. That's really powerful for you to reason about that code. And now we got what we want. So the idea here, just to make a little bit clear, is that in your ports that you're like calling the controller function, you're still calling the controller function, but you're holding the dependencies. Like, I'm the port, I have the DB, I have the producer. I'm holding them, I'm passing only the card to the controller. When the controller returns to me with the structure, then I call what I need to call. Then I'm going to call to the save, I'm going to call the produce. So I hold those things. We are already testing the ports only with integration tests, so we are not losing anything from those tests, and we are getting that from the controller. So now, really, my port's doing everything, and I just gained that second layer. Just if you want to look for things that talk about that, I don't know if you ever heard about free monads, but it's a similar idea. At Nubank, we created a runner, because now that we know those things, we want to have consistency. So, for example, I always want to save everything in the database before producing new messages, right? You don't want to produce a message saying new status before saving to the database. You can get an error. But for the developer needs to take care about it, and you can forget. You can just produce the message before saving things. So now that I'm not doing anything in the controller, I'm always returning a map with all things that I want to do. I can create my runner. My runner says, okay, first I save the datums thing, after I save the message thing. If something fails for the datums, because I'm checking for idempotence, right? So I already have that in the database, I get an error. Oh, I'm not saving that again. But I want to produce the messages again, because all my systems should be idempotent. And then you can create your little runner for those things, because you know that the controller is always producing these structures that you can create how you want. You can think about the keywords that you want to give for them, and that's like really, really powerful. So what we got, the second layer without side effects, we became more expressive, like data is now flowing through a rep. So we are telling much more about those controller functions that we are not telling with integration tests. Pure functions, tests and maintainability, going like this step further. It's important to say that was already really good with the hexagonal and dependency injection thing. But we are going to the experiments like 2 months now, and we are really happy with like increasing the test for the controller. We are able to get some mistakes. We are always thinking about what we want to return. It's easier to compose because you usually say things and then produce messages, a lot of those things. So it's been a nice experiment. And that's it. Thank you, and we are hiring at Nubank for some remote positions also.
I think we have time for 1 or 2 questions before going to lunch. So, any questions? 1, 2. You can, pueden hacer las preguntas en castellano y yo se las traduzco, no hay problema. No? Okay. Lunch is, I don't know. I believe it's in the same, castellano. El almuerzo es en el mismo lugar que fuimos antes.